Hello everyone, it's Jihan. Today I'm going to talk about some sample problems for homework 4. And there are some problems in homework 4 is like similar to the homework 3 problems. So I will not go over that in this video. So if you have concerns about that part, you can review the homework 3 sample video, Okay, let's get started. A certain geneticist is interested in the proportion of males and females in the population who have a minor blood disorder. In a random sample of 1,000 males, 250 are found to be affiliated, whereas 250 of 1,000 females tested appear to have the disorder. Computer 95% confidence interval for difference between the proportion. So it's a problem about the difference of the proportions. So from the question we can know for male is 1,000 and there are 250 have blood disorder, and in female it's 1,000 but only 275 is disordered. So you want to have the P1 minus P2, the CI for that. Okay, from the lecture notes we can know the probability for the CI for this is P1 minus P2 between P1 hat minus P2 hat minus normal distribution with alpha over 2, then square root P1 hat minus P1 hat times 1 minus P1 hat, then divided by N1 plus P2 hat 1 minus P2 hat, then divided by N2 to P1 hat minus P2 hat plus the alpha over 2 square root P1 hat 1 minus P1 hat N1 plus P2 hat 1 minus P2 hat N2. So that's a formula you can get from the lecture video. So we have to calculate the P1 hat and the P2 hat. It's easy to calculate, just 1,000 over 250 equals to 0.25, and this equals to 0.275. So then the z alpha over 2 square root P1 hat 1 minus P1 hat and 1 plus P2 hat 1 minus P2 hat and 2. This equals to, as we know, like z 0.95% confidence interval is 0.025, and this is then divided by 0.25 times 0.75 divided by, there are 1,000 of them, plus 0.275 times 0.725 divided by 1,000. So we can get the value is, this value is, as we all know, is 1.6096. So it is 0.0386. So we just need to use and the P1 hat minus P2 hat is minus 0.025. So we just use get the number we need equals to minus 0.025 minus 0.0386 to 0.025 plus 0.0386. Then we get the value. This value is minus 0.064, then 0.014. That's the answer for this question. So you just need to find the right formula from the course lecture. So you can know, you just apply those numbers to the formula, then you can get the answer. Now let's look at the second question. This is a survey of 1,000 students found that 264 chose professional baseball team A, with 1,274 choose baseball team A as their favorite team. In a similar survey involving 760 students, 240 of them choose A as their favorite. Compute a 95% confidence interval for a difference between the proportion of students favoring team A. And is there a significant difference? So it's a similar question with the first one. Just the first survey contains like 1,000 students and 274 choose A. And at the second survey, it's like 760 students and 240 choose A. So we just use the same formula. First we get the P1 hat is 0.274. Then P2 hat is 240 over 760. This equals to 0.3158. So what do we need else is this thing is z alpha over 2 square root p1 hat minus times 1 minus p1 hat over n1 plus p2 hat 1 minus p2 hat over n2. So that is 1.96 and square root 0.274 times 0.726 divided by, this is 1,000, and minus or plus 0.3158 divide times 0.6842. Is that right? Yeah. And divided by this n2 here is 760. So we can get a value. This value is 0.0431. And for the difference between proportions, it's P1 minus P2. The confidence interval for this is 0.274 minus 0.3158 divided by 0.0431. Then it's 0.274 minus 0.3158 plus 0.0431. So this equals to minus 0.0849, then 0.0013. So can you tell is there a significant difference? Because this confidence interval contains 0. This is minus, this is plus, this is positive. So it contains 0. That means we cannot tell there is a significant difference. So it's no significant difference. Okay. So that will be the answer for this question. Okay, let's go to the next question. The following data represents the running times of films produced by two motion picture companies. Here's the data for the film time for two companies. We will not look at this question. So here they assume that the running time difference are approximately normally distributed with unequal variance. This is unequal variance. That's the assumption. So look at this. Construct a 90% confidence interval for sigma 1 squared divided by sigma 2 squared. In this problem, should we assume sigma 1 squared equals to sigma 2 squared when constructed the confidence interval for the mu1 minus mu2? Okay, we'll just focus on this problem, okay? So this is problem for confidence interval for sigma 1 squared divided by sigma 2 squared. This is the two sample variance case. This is covered by the lecture. So from the lecture we can know the formula for this problem is like probability S1 squared divided by S2 squared, then F distribution 1 minus alpha over 2 and 2 minus 1 and 1 minus 1 is less than sigma 1 squared divided by sigma 2 squared, then less than S1 squared, S2 squared, F distribution alpha over 2 here, then N2 minus 1, then N1 minus 1. So we need to pay attention, like here is first N2, then N1. That's the thing you need to remember. Okay, so you can calculate the variance for those two companies with the Excel. Through the calculation, we can know S1 squared equals to 76.3, S2 squared equals to 1035.90, and what left is the F value here and here. And the alpha is 0.1, right? So the 1 minus alpha over 2 is 0.95. Then N2 is 7, so it's 6, and then 4. And the next value we need is 0.05, then the same 6, 4. So I'll look through the table here. So for alpha value is 0.05, and what we need is 6.4, right? 6.4 here, 6.16. This is 616, and the F value table do not have the alpha equals to 0.95, so we have to do a little bit of calculation here. From the lecture we can know it's equals to 0.05, then 46, right? If you can remember. So it's 1 over this value. This value we can look through the table. It's same the 0.05, then 46. 46 here is 4.53. 4.53. So we can get the confidence interval for alpha sigma 1 squared divided by sigma 2 squared here. This is 76.31035.9 times 1 over 4.53. Then the same 1035.9. Then times 6.16. So this value equals to 0.01626, 0.45372. Then we have the answer for this problem. That's for today. Thanks for watching.